how many atoms are present in each of these formula units. So what we're doing here is we're simply counting how many atoms are present in whatever is being listed here. Now, one of the first things we want to do is notice that this quantity in here, quantity within the parentheses, there are 2 of whatever is inside here. Now, what is inside here is 1, 2, 3, 4, 5 atoms, right? 3 oxygen atoms, a carbon, and a hydrogen, for a total of 5 atoms. There are 2 of those things, so that gives me 10 atoms just with this this anion here, and then we have an extra calcium in front, so that gives us 11 total. Looking at this sugar right here, I think that's sucrose. We have 12 carbons, 22 hydrogens, and 11 oxygens, so we'll just add those together. My arithmetic tells me that's 45. 45. You guys can check me on that one. But because there are no quantities in here, quantities within parentheses, I'm just adding all of the subscripts together. But down for C, we have another quantity. Within the quantity, I have a chlorine atom and 2 oxygen atoms, so there are 3 atoms within this parentheses. There are 3 of those items, so that's a total of 9, plus this single iron atom, so I'm looking at 10 atoms. Now I'm going to change things up a little bit. Notice that this looks very familiar. Notice it's very, very similar, but these 2 subscripts have been changed. We'll see if that affects our overall composition. Now inside the quantity, inside the parentheses, I have 1 chlorine, I have 3 oxygens, so that's a total of 4 atoms within the parentheses. I have 2 of those, so that's 8, plus my 1 iron atom, give me a total of 9. So yeah, it does affect the total number of atoms present. And so we need to be very, very careful on how we maintain or conserve our subscripts when we're writing chemical formulas.